In the last part, we had learned about the chemical properties of metals, and we had learned two properties of metals, that is reaction of metal with oxygen and reaction of metal with water. Now in this part, we will be learning few more chemical properties. The third property is the reaction of metal with acids. What will happen if metals are treated with acid? So for this, we are taking an experiment. So what we have to take here is you need apparatus like we need a stand, we need a test tube, we need cork. For this we have used a bent tube, and here we have taken some water in bucket. Now this is soap water. In this test tube we have taken hydrochloric acid. Now this is dilute hydrochloric acid, and we have taken zinc granules here. Now what happens when you add the zinc granules into it and you close the entire apparatus? So as soon as you add the zinc granules, you will see that the bubbles of hydrogen gases are formed. So this hydrogen gas is released, and this hydrogen gas is then passed through this tube, and from here you get the bubbles, and these are the soap bubbles. And if you have to test these bubbles, okay, what is there inside? So for this you can take a candle, and you will see that hydrogen gas burns with a cracking noise. So this is the experiment that we are doing. So from this we conclude that whenever you treat any metal, now zinc is a metal, so when you treat metal with a dilute acid or with any acid, so hydrogen gas is given out, and also something remains behind, that is the chloride. So they form the chloride. You can take any type of metal like aluminium, zinc, or any metal. So when you treat it with acid, so sulfate or the chloride salts of metals are formed, and the hydrogen gas is liberated. Now also the reactivity of these metals, now you can take any metal like magnesium, aluminum, zinc, and iron. If you are taking four metal, so the reactivity of metal in is this way. First you have magnesium, which is greater than aluminum, which is greater than zinc, and which is greater than iron. So we can write the equation when magnesium is treated with hydrochloric acid. So it gives what? Magnesium chloride, and hydrogen gas is given out. Same happens with aluminium also. When aluminium is treated with hydrochloric acid, it gives aluminium chloride and hydrogen gas is given out. When iron is treated with the hydrochloric acid, it gives iron chloride and hydrogen gas is given out. Same with zinc. If you treat solid zinc with hydrochloric acid, zinc chloride is formed and hydrogen gas is given out. So from this we can conclude that whenever any metal is treated with acid, so the chlorides are formed or the salts are formed, sometimes even sulfates are formed. So sulfate or chloride salts of metals are formed and hydrogen gas is given out. Fourth is the reaction of metals with nitric acid. What happens when we treat metals with nitric acid? So whenever you treat metals with nitric acid, nitrate salts are formed, and also the oxides of nitrogen are formed. You can get nitrogen oxide, that is NO2, or you can get NO nitrogen oxide, nitrogen dioxide, and these type of things are formed. So that means nitrate salts are formed and the oxides are formed. So here now we have taken the example. So first is the copper. When you treat copper with the nitric acid is HNO3. Now here we are taking concentrated and dilute both. So first when we treat copper with concentrated nitric acid, so we get the salt, that is copper nitrate. Then we get some oxide, that is NO2, nitrogen oxide, and then we get some amount of water. So that means salt, and that is the nitrate salt, and the oxide is formed. Now if we treat the copper with dilute nitric acid, so we get again salt, that is copper nitrate, we get NO now, and we get water. So this is the reaction. We can conclude from this that nitrate salt and the oxides are formed when you treat metals with nitric acid. Now next is the reaction of metals with salts of other metals. What will happen when the metals are treated with salts of the other metals? So for this we are doing an experiment. We are taking two test tubes. In this test tube we have taken a thread, and here we have taken a nail. Here also we have taken a thread and nail. Now in this test tube we have taken the solution of copper sulfate, and in this test tube we have taken the solution of ferrous sulfate. Okay. Now here we are putting an iron nail in this test tube, and in this we are putting an copper nail in the ferrous sulfate solution. Now these are both opposite. This is copper sulfate. Copper sulfate is the salt, and this is the iron nail. Here is ferrous sulfate. Ferrous sulfate is the metal salt, and we have the copper wire here. Now, when you will remove this copper wire and the iron nail after some time, we will see that on the iron nail, a copper coating is formed. And this coating is because of the nature, that is electropositivity. They lose their electrons and a substance gets developed into it. And this is also called as the reactivity of the metals, and the reactivity of the metals is in series. We will now learn about the reactivity of metals. Now from the previous experiment, if we will see, so the displacement reaction took place there. Okay, so there was a displacement reaction, and that was the reason why a copper coating was formed on the iron nail. So if from this displacement reaction, we can actually identify which metal is more reactive. So from that experiment, if we will see, so if here what had happened, that this copper which was there, the copper solution was there, okay, and we had taken iron nail here. So when you remove this iron nail, we found that on the iron nail some copper was present. Okay, so that means what happened, ये जो iron nail था उसने इसके solution में से, ये जो copper sulfate solution था उसमें से copper को displace किया, and that copper comes on this iron nail. Okay, so from this we can identify that the iron nail is more reactive than the copper, because the copper was displaced because of the iron. When you will remove this copper wire, you won't see iron substances on top of that. You will only see the copper coating on the iron nail. You won't see the iron coating on the copper wire. So from this we can conclude that if a metal A displaces another metal B from the solution of its salt, then it means that metal A is more reactive than the metal B. So that means what happened? Our iron nail was metal A, and the solution was there, that was the B, and this metal A removed the metal B. Now what is metal B? That is copper. Copper is being removed from the salt, that is copper sulfate में से copper remove हुआ, and it came where? It came on the iron nail. So that means iron is more reactive than copper. So from this experiment, in these way only, we have concluded that these many chemicals are more reactive, these many solutions of salts, and then we had put in the iron metal into it, and different types of metal we have taken, and we concluded that which of the metals are more reactive and which are less reactive. So these metals like potassium, sodium, calcium, magnesium, aluminium, these are the most reactive. Then these zones are the moderately reactive, and these like copper, mercury, silver, gold are the least reactive metals. So this is called as the metal series. So this is the reactive series of metals, in which the arrangement of metals is given in the increasing and decreasing order of their reactivity, and this is the reason why it is called as the reactive series. Now here you can see there are three groups: highly reactive metal, moderately reactive metals, and less reactive metals. Next is the reaction of metals with non-metals. So what reaction takes place when metals reacts with non-metals? So now metals, they usually lose their electrons, and the non-metals gain that electron. So for example, when you react a metal with a non-metal, so they will form an ionic compound. So if Na, that is a sodium metal, and Cl, that is a non-metal. So when chloride, which is a non-metal, it combines with Na. Na loses electron, chloride gains the electron, and it forms an ionic compound, that is NaCl. Same way, Mg and Cl also reacts, it forms MgCl. K and Cl also react, they combine together to form KCl. Next is the chemical properties of nonmetals. Now we have seen about the physical properties of nonmetals. Now nonmetals are electronegative elements. Now why they are electronegative is because they gain the electron and they develop a negative charge. We have seen in the electronic configuration we had made that whenever anything that loses electron, it gains a positive charge, and someone who gains the electron, it develops a negative charge. So nonmetals are the substances which gains the electron and develops a negative charge, and this is the reason they are called as the electronegative elements, as they form negative charge by accepting the electrons. The first chemical property of nonmetals, the reaction of nonmetal with oxygen. What happens when nonmetals react with oxygen? So when nonmetals react with oxygen, they can either form an acidic oxide or they can form the neutral oxide. Both can be formed. So if here we will take, for example, when carbon, it combines with oxygen, so it forms carbon dioxide, which is acidic. Now here carbon is combining with oxygen, but here there is no entire combustion, only partial combustion is taking place. That is why carbon monoxide is formed, which is neutral. When sulfur combines with oxygen, it forms sulfur oxide after complete combustion, which is acidic. So we can conclude that acidic oxides and neutral oxides are formed. Next is the reaction of nonmetals with water. Now, nonmetals usually do not react with water except the halogens. Now, there are 5 halogens which are there in the periodic table. Those are called as halogen, for example, chlorine, bromine. So, when we take chlorine, so only those 5 or 6 halogens, they react with the water, except no metal, non-metals react with water. So, when you take chlorine and you treat it with water, so it dissolves in the water, and after this reaction, that is after dissolving chlorine in water, we get hypochlorous acid and we get HCl. Next is the reaction of dilute acid with nonmetals. So now nonmetals do not react with dilute acid, only the halogens reacts with dilute acid. So again, now we are taking chlorine. So chlorine reacts with the hydrogen bromic acid, that is hydrobromic acid. And here you can see the reaction. We can see that hydrogen chloride is formed and bromine is formed. Next is the reaction of nonmetals with hydrogen. So the nonmetals react with hydrogen, but under certain conditions, like they need proper temperature. Also the use of catalyst should be there. For example, if we take sulfur, sulfur is mixed with hydrogen. So we get, that is H2S, which is hydrogen sulfide. Next, if you take nitrogen and if you mix it with hydrogen, so we will get ammonia. So these were the few chemical properties of nonmetals.